Hi everyone. Today is day number 12 uh, of our 30 days 30 machine learning projects challenge. So let's start. It is predicting airline passenger satisfaction from gradient boosting machine. Let's Here it is day 12 and here is the problem. Uh, yes. Um, Please explain what GBM is in easy words. Also, uh, tell where can I get the data set from. Let's wait what ChatGPT has to say. Hmm. What I'm really liking about this challenge is that uh, on day one, two, three, five, six, like 7, 8, 9. So on each day, I'm exploring something new that have I have never heard of, or few models I have heard of while I was studying or reading the theory from the Coursera courses, or this course particularly machine learning. Sorry, yeah, machine learning specialization from by Stanford University and deep learning AI, and then from Kaggle the introductory and intermediate courses there. So I did understood, but solving the challenges or solving the problems is teaching me way more than I learned from these courses altogether, like in months. So yes, I recommend everyone to solve the problems, and then while doing the problems, you learn about the algorithms. So that is really working for me. So I would recommend someone else to do the same. So let's start and stop this. Okay, so it says gradient boosting machine, which is the model that we are going to use today or explore today, is a powerful machine learning algorithm used for both classification and regression tasks. Okay, we have done both type of tasks until now. It is based on the idea of creating a strong predictive model by combining several weeks. Okay, several weak models. Okay, typically decision trees, and here's how it works. So we have worked and understood how decision tree work and what they are. So it is going to use combine several weak models like decision tree. So weak model, it starts by training a simple model like a simple decision tree that does not predict the target value well, but captures some patterns. Okay, improving over time. Instead of building one big tree, GBM builds multiple small trees, each trying to correct the mistakes, error made by previous tree. This step-by-step improvement process is called as boosting. Okay, I guess we did something in past also. I guess for let's go back to our post. And here I remember when we did isolation forest, or I guess there was one more random forest. Not random forest, there was this forest which is a collection of decision trees, and there also we were specifying multiple type of iterations, right? I guess yes, passive aggressive classifier. No, no, here we were. So yeah, here it is using multiple type of many decision trees, and today also we are going to go ahead with something like that. Gradient boosting machine, combining building weak decision tree, multiple decision trees, small trees, and each trying to correct the mistakes made by the previous one. Okay, so this step is, and this is called boosting. Okay, now, GBM uses a technique called gradient descent, which is to minimize the errors made by the model. The idea is to add a new tree that predicts the error residuals of the previous tree. Over time, the model gets better at predicting. So, okay, so it uses this technique called gradient descent. Gradient descent is a technique where it improves from the previous mistakes. If I go and show you, देखो, see, sorry, I use Hindi word. Gradient descent is a method for unconstrained mathematical optimization. It is a first order iterative algorithm for minimizing differentiable multivariate function. Okay, and if I see curve, okay, see, this is how it is minimizing the errors, and there it comes a point where uh, the error is minimum. So and then the error starts increasing again. So this is called gradient descent. And then the final model of iteration, GBM combines all the small trees to create a strong model that performs. Yes, GBM combines all small trees to create a strong model that performs well on the task. In short, GBM is like building a team where each member focuses on fixing the mistake made by the others, ultimately leading to a higher accurate prediction. Okay, understood. For predicting airline passenger satisfaction, a commonly used dataset is available on Kaggle, and the dataset is called this. Let's see if it no it the linking it does not work. Okay, like you can download it. I have downloaded it. Let me go unzip it, and okay, I do see train and test. It contains data on various aspects of the passenger experience, such as in-flight service, seat comfort, cleanliness, more, which you can use to train your GPM model. Once you download the dataset and place in project's dataset directory and proceed with building, let me know. Thanks. I have downloaded the data set and placed in the data set directory. Let's start the code flow. Okay, I guess it is done. So it is loading the data, pre-processing the data, checking the missing values, dropping the missing values. Okay, into a numerical using one hot coding and coding. Okay, creating the features, putting the data, building that and train the GDM. Okay, predictions, and then evaluate the model using confusion and visualizing it. Mhm. And what type of problem uh, is it a classification type problem or regression? I guess this is a classification type. This is a regression type problem. Then, if it is, then why are we using confusion metrics? This is what I want to ask. Why the target variable satisfaction is typically a categorically variable with distinct classes. Okay, it is satisfied, not dissatisfied. So it is we are classifying amongst these two classes. Okay, but the task is to predict which of these discrete categories are categorize a passenger falls into. Okay, discrete categories of passenger falls into, making it a binary classification problem. Okay, if there are only two classes, satisfied and or dissatisfied, or a multi-class classification, there are more than two categories. Regression problems, on the other hand, involve predicting a continuous numerical values. Correct. So I thought we have to predict the satisfaction on a scale 0, 1, 2, 3, 4, 5, 6. Even then, it would have been a classification problem. Yes, yes. So sorry. Even then, it would have been a, yeah, classification problem. So it is a classification type problem. Then it makes sense to see or have the confusion matrix. Let's start. So let's start. Create a class, create a file, day, let's refactor it, rename day 12.py, and the problem is, okay, and it is a classification type problem. So here what we have to do, if we have to classify passenger, it is a binary classification problem. We have learned something new today. I guess I have heard this term before also. Classification problem. So what we have to do? Start. Import pandas as PD. Step number one is load the data. Here we are loading the data. So we are data is called as pd.readsc. It is data set, and it is going to, let's, we have not moved it, right? Okay, I was just checking. Gender, age, class. Hang on, let's load it. Let's load the train. I will name this as, I will name it as, and I will name this as airline satisfaction test train, and move it to, actually sorry, the wrong folder. So yes, I will use the terminal for that. So downloads, archives, it is archive 6, 6. I have to move all to data set, and let me see, yes, I can see both the data sets moved here. So I'm going to use airline dataset train, and then print data dot head. Clear the terminal and run this file, and it is going to be day 12.py. So I have this satisfaction, which we are going to use as the target. Then we have other features. Okay. So I don't think we'll have to split today because we are getting separate data for train and test. Okay. So data train, I have to, so from Kaggle, I get two separate files for train and test. I we think today we don't not have to split the data. Let's read what ChatGPT has to say. There is no need to perform an additional data split. Instead, you'll use the provided training data for model training and test for evaluation. Okay, correct. See, so this is train data, train data, and this is test data. Read CSV data set airline test, and it is train data, and we are printing test data. And let me clear it and run this file, and I can see the train data and test data. Okay. And if I want to see the shape, then I mean how many columns, how many rows does it has? Okay. Okay. So yes, we are sorted with that. Now we have to do pre-processing. Step number 2 is pre-process the data. The training and test data. So what we have to do? Okay, first we have to drop the missing values. So train, for that what we have to do? This train dot drop the missing values, and in the test data also we will drop the missing values. Okay, understood. Then convert the categorical features of to numerical using hot encoding. What is in when I was, if you would also go and understand, follow the Kaggle introductory course, you will see hot encoding described there. So I will ask ChatGPT to explain it once in easy words so that we all can understand what it is. Can you please explain in easy words with examples what is and how it works? Let's wait for ChatGPT to finish it. Hmm. So what it does, one hot encoding is a technique used to convert the categorical data into a format that can be provided to machine learning algorithm, which typically requires numerical input. Let's break it. So machine learning algorithms require numerical input to function. Now, if we have data which is not numerical, so if we have to convert it into a numerical form, we use encodings. One hot encoding is one of those. Now, categorical data consists of the values that are labeled, not numbers. For instance, if we have a column for gender in a data set, it could have values like male and female. Okay, this is a categorical, yes, data. Um, Now, why can't we use categorical data directly? Because machine learning algorithms work with numbers, not text. If we find algorithms categories such as male or female directly, it won't understand how to process them. One way to convert this data is by one hot encoding. Now, what is a one hat and one hot encoding? In one hot encoding, each category is transformed into a new column. Okay, and the values are represented with zeros and ones. And here is how it works. For example, for let's say we have a column class, and in the column of that class we have three categories: economy, business, and first. Now, for example, for row number 1, the passenger ID 1 is flying with economy, 2 is flying with business, 3 is flying with first, 4 is flying with economy. Now, with one hot encoding, after applying one hot encoding, the class column, okay, would be replaced by three columns. So, if we have three categories, we will have three new columns, and this class will be replaced by three new columns: class underscore economy, class underscore business, class underscore first. If a passenger belongs to the category, the corresponding column will have a 1. If the rest will have, and the rest will have zeros. Okay, for example, for passenger with ID 1, it is going to be, it was economies, right? So it is going to be 100. Similarly, for 2, it is for business, it is 010, and rest we can see each row. So if the value is going to be economy, it is going to be 1 for that passenger, otherwise for all of them it is going to be 0. Okay, how does one hot encoding help? One hot encoding helps by converting categorical data into numbers, making it possible for machine learning models to work with the data without interpreting the categorical values incorrectly. For instance, if you had converted class into 0 and into 0, for economy 1 into business 2 for first, the model might think that the first two, economy and business, first two is twice as important as economy. Okay, this is as important, twice as important as economy, which is actually not the case. They are simply the labels, right? So in that way, one hot encoding prevents that unintended assumptions. Understood. So where what it is doing, it is converting a textual data into, or a categories into their respective columns, so that machine learning algorithm can better understand it without the unintended assumptions, right? Now let's go back and use use one hot encoding to convert categorical classes to their respective columns that machine learning algorithm can understand. So what we are doing? Okay, so what we are doing? Convert categorical features to numerical using one hand. Okay, features. So what we are doing? We are using get dummies for train, drop first. Yes. So we are using train data partner. We are using get dummies, train, Drop first, true. And I am going to print it so that I can understand. Dot head. Let's run it. See, it is converting using on head. So it is using this function called get dummies. Uh, let's hover over. Maybe we can get some idea. Convert categorical variables into dummies or indicator variable. Each variable is converted into zero into in as many zero one variables with their different values. Columns in the outputs are each named after a value. If the input is a data frame, the name of the original values is prepended to the values. Okay, see, so this is the function that is used for applying one hot encoding on train data. If I mark it as false, let's explore what it will do then. Okay, is you see it is so class economy, class eco, class. Now the columns are intact. The original columns were intact, right? See, satisfaction, neutral, or dissatisfied. Satisfied. See, see. So this column was kept intact. Now we are saying we do not want this column. So now if we run it, we should not see these columns. Yes. So we are saying that drop the columns that you are converting the columns that are having categories that are having categorical data. Okay. So we will do the same for test data. It is going to be get dummies test data drop first. Yes. Now we will do what? Uh, ensure both data sets have same structure. Okay. Okay, so we are converting satisfied to 1 and converting neutral or dissatisfied to 0, because of course machine learning will understand to a 0 or 1 the target value, right? So uh, in the okay, we are saying train data satisfaction where satisfieds are mapped. Okay, so let's do this. If I want to print train satis satisfaction, and if I run it, will I get any error? If I want to see only one column data in panda data frame, like is it correct? Let's see what it says. But see, it does not have. If I say false and then I run it, true, I'll comment it and run it, then okay. So it is dropping the. If I run this, okay, and if I do this, okay, if I do, I should be doing one train, right? I'm getting an error. If I comment this, I'll get the satisfaction. So I'm Dropping here, I'm dropping the original one, right? So why do I? Why would I? Why? How can I access it, right? I think I should be doing it later. Let's do this. X train. Here, let me apply it and see it will work or not. Okay. So here we are convert doing what? Ensure uh, both data set have same target value for consistency. So what we are doing, we are saying X train is going to be our train data dot drop satis satisfaction access 1. We have to drop the column and run it. This it throws error. Don't you think we should convert one hot encoding later as when as uh, is is deleting the data original features. I think you should be doing it later, right? But let's wait what ChatGPT has to say. Yes, correct, correct. So we should do one hot encoding later after we apply map the data completely. Apply after separating. Correct. Right? See, I was right. And I'll comment it for now, and I'll move it later to after fixing the value for satisfaction column. Let's run it. I should be able to run it. Then x y train is going to be train the satisfaction column. Here we will apply map uh, these satisfaction will be mapped to 1 satisfied, sorry, this satisfied will be mapped to 1. Check satisfied or nil satisfaction. Satisfied will be mapped to 1, and this neutral or dissatisfaction will be mapped to 0. Is it correct? This is going to be our feature. This is going to be our target value. Okay, let's print the x train dot head. Let's print the y train dot head. Let's rerun it. So we have dropped the satisfaction, so we should not see satisfaction from the training data. And for the target values, we should see the satisfaction in 0 and 1. Perfect. Now do the same for test. So x test validation. We are going validation is going to be test data. Drop the satisfaction. Drop not the missing values. Drop satisfaction. And what column we have to drop? and we will say the validation uh, target values for validation is going to be test data, uh, satisfaction column, and map the same thing. Map satisfied to 1 and neutral or dissatisfied to 0. Print the x value head, print the y value dot head, and rerun it, and yes, it is working fine. Looking good, looking good. Now let's remove it and then apply, move it here, and now print the things. So print train data dot head, not train. I guess we have to apply on x train. We have to apply, right? X train. We have to do this, not the complete train data. And here we have to do x validation, x validation, x train, and x validation. And let's run, clear the terminal and run it again. See, I should be seeing the columns of features with true, false, true, false, true, false, true, false. So this is how it is looking. I hope that is correct. This is how the data is looking after applying the one hot encoding. I hope that is correct. Hello, yes. Sorry, I got a call and they were calling like twice. Yes, so after applying, your data looks correct. Here's a quick ensure everything is good. Okay, okay, cool. So if our data looks cool, let's go to the step number three. Step number three is going to be, step number three is build and train the model. Now we will do what? Step number three is build and train. So we are going to import the model from sklearn ensemble, the gradient boosting classifier, and we have already understood how it works. It works by using building lots of weak small decision trees, and each decision tree is built on the mistake or the flaw of the previous decision tree, and it keeps on doing like in gradient using the gradient descent technique. I show you, like, keep on generating, doing it so that it reduces the loss, and it reaches a point where the loss will increase. So we have to find that loss here, I mean the minimum point here. So this is how the gradient boosting classifier will work. So from sklearn ensemble import gradient boosting classifier, from sklearn matrix import accuracy score, confusion matrix, sorry, fusion matrix, and classification report. So let's come here, and then we will build model is going to be gradient boosting algorithm, sorry, gradient boosting classifier. The random state is 42. Again, I guess, let's see here, set in Gradient boost boosting classifier is used for what? Let's understand. Uh, we have used this thing, I guess, a lot, and I guess it is used to control the randomness in the algorithm. It ensures that the results are consistent every time we run the code. Exactly. For every for I guess for everything where we have to keep the consistency. Whenever we are running the code, we pass this random state to 42. 42 is a random number. Then we are going to train the model on X train against the Y train values. Let's see if that is, because in the last problem the pattern got changed a little. So let's go back. Yes, Y train. Yes. Now, step number 4 is make predictions and evaluate. So what we'll do, um, predictions are going to be model dot predict what predict x value, and the accuracy is going to be accuracy score of the original value, which is the y value. Yes, y value and the predictions made. Is that correct? Yes. And we will print it. Print accuracy score is accuracy score. And parallelly we will print the confusion matrix. Confusion matrix, it will build between the original values, the actual values, and the predictions made. We will print the result. Confusion matrix is confusion matrix, and then we will see the classification road amongst the between the actual value and the predictions made, and print it. Report, and we will run it. It is taking time. Let's wait a little. Okay, the model is performing good. It is getting 94% accuracy. Then, yes, 0 1. What was 0 again? The 0 was not satisfied. So let's print it. Let's print this confusion matrix. Then we will get better idea. Classification. So let's visualize it. The accuracy is coming as 94%. So here's the output. Okay. Step 7, not 7. Step 5 is visualization. Let's visualize this confusion matrix to understand more about the true positives, false positive, how many rows, or for how many passengers we have correctly predicted the satisfaction, and for how many passengers we missed predicting correctly. So yes, let's do that. So for that we will import matplot as plt. We will import cbon as sns, because this will give us the function to build the heat map. So first we are defining the figure. The dimensions are going to be 10 is to, let's say 7 is to 5. Then I'm going to create the heat map, and here the heat map will be on the confusion matrix. The annotations, yes, I want, and the format is going to be D. Format will be D, right? Okay, it is building a bar graph, but let's see, and then I will use the bar graph. And here the color is going to be blues. The X tables are going to be uh, for zero it is going to be, for zero it is going to be, let's see what we have defined earlier, where mapping we did. Yeah, for dissatisfied or satisfied, dissatisfied and satisfied. And let's do this. And y tick tables are going to be same, except it is going to be D. It is going to be D, right? Let's now come here. Copy it. Okay, line too long. Then we will have the X label as the predicted values. Plot Y label is going to be the actual values, and the title of the plot is going to be confusion matrix, and then we will just show it. Let's run it, and we will now understand. So yes, let's wait a little, and it will show the figure, and we will understand the meaning of confusion matrix. So the okay, let me go and see how, in what way we have to specify that. Okay, it is going to be true. See, I made a mistake here. True. It was taking as one only. I will remove it. Rerun it. We have to do. Now it is getting better. Rerun it. Okay. So in the predicted satisfied values, and they were actually satisfied. So the predicted satisfied values are, customers are 10,468. The correctly predicted dissatisfied passengers are 13,990. The incorrect values for satisfied customers were made, passengers were made 609. The incorrect uh, values predicted for the uh, satisfied, as in predicted as dissatisfied, and they were satisfied, is 897. So this is why we see these two numbers are correctly predicted, and they are very high in numbers. So that is why the model is performing really good here. The model is performing 94%, so which is really good uh, accuracy. And now I want to see what we are doing here, how we are visualizing it. uh, mhm. Feature importance for passenger. Okay, we want to see why. Okay, let me save it and close it. uh, Here it says that we will utilize the most important features that influence passenger satisfaction using the feature importance from the GBM model. uh, okay, we want to understand what features are are important for getting the good satisfaction from the customers. So what that we can do, for we have to import this numpy, import numpy as np. Okay, and I will say, can you explain this in depth? Yes, can you please explain the visualization step in detail? Okay, so yeah, let's understand it. Let's break down the visualization step in detail. So we will understand what is feature importance. In machine learning models like gradient boosting, feature importance helps us understand which features have the biggest impact on model's prediction. This can help us switch. Okay, we have to identify which features are the ones that are creating biggest impact on the model's prediction, as in whether the user is satisfied or not satisfied. This can help you see which attributes like age, flight distance, or type of travel are most critical in predicting passengers satisfactions. Yes, now here what we are doing, let's go see. Here we are finding the, okay, correct. So here what we see, here it is, in the step we are calculating the important features. The from the model feed, acha, model only returns a key which lists the important features. So we can get this thing from important and features visualization. So first, feature importance. Feature, we'll say feature importance visualization, and this is, okay, feature importance is going to be from the model feature importance key. Okay, and we will print it, clear it, run it, and we'll understand that. It provides the list of the important scores for each feature in the data set. Higher values indicate that the feature plays a more significant role in predicting the target variable. Okay, that is the satisfaction. And then we are going to sort the important features. We will hide it and then see. These are for feature number. So we had how many features? We had these many features, and this feature has this value, the importance number. This has this. Amongst this, the ones which holds higher value are going to be the important features. So for that we will sort it. So we use numpy for that. Numpy uh, and sort here returns and indices that would sort and perform an indirect sort along the axis using the algorithm specified by the kind keyword. It returns an array of indices. Okay, it is going to return the indices, and we've on what we are going to do on feature importance, and we are going to store in the sorted index of important sorted indexes in by their importance quotient. So sorted index, and then we will run this model, and then we are going to create. Okay, we are going to simply create this sorted index as the bar graph for each column. This x dot column sorted index feature importance this. Okay, let's see. Okay, in this way the importance is calculated. 0 has more importance, 18, 20, 8, 7. Okay, okay, good. Now, for creating the plot, the size of the plot, the plot dot bar creates a horizontal bar chart where H stands for horizontal. Okay, it is a bar chart and it is a horizontal bar chart where H stands for horizontal. It will plot the feature names. Okay, feature names for each. Okay, feature names in this form. For it will print the feature name of this, and then this, and on the y-axis their corresponding importance values. Okay, and then the corresponding importance value will be printed on the y side. Okay, and the color is going to be teal. The label, x label, y label, and the title, and then show. Okay, let's see it. We are going to have plot dot figure. The size is going to be 10 is to 7. Then we will have, because we are going to have many, let's see how 10 is to 8. We are going to have columns. I mean, it is going to look large. Then it is going to have a bar h where it is a horizontal bar chart, and it is going to be on the on the x side. It is going to be x train, x train. uh, where are we training, right? We're training on this, right? So x train sorted index. So the label for the x, if for the bar chart, is going to be the feature, sorry feature name, and then presented in the sorted index order. And it and the y side, it is going to be the importance quotient, importance feature importance value for the in sorted index order. And the color, sorry, teal. Yes, and then the x label is going to be importance, y label is going to be features, and we'll put it in as string. The title is going to be feature importance of passenger satisfaction prediction, and we will show it. Let's clear the terminal and run it again. Okay, the confusion matrix we have already understood, and this is the importance. On the right side, we see the importance. So yes, online it is showing online boarding is this much. Flight has then, so online boarding has the highest importance. Let's increase the size a little. Let's increase. Let's run. Then we have, let's close it and run it again. Probably then we will be able to see all the keys. Hmm. Okay, we've already understood that. Yes, correct. Now it looks a little better. So online boarding is looking like that. This here it is looking like that. So online boarding has the highest importance. Then in-flight Wi-Fi service is more importance. Uh, okay, ease of travel, personal travel is it is, we cannot see the full title. Economy class has more importance. So this is how it is coming, right? So yes, okay. I want to see how it was calculating. Yes, in the original. Yes, correct. And do I need to change it X only? Train, train data, X train. Then it changes that X train to, yeah, X train. So let's ask ChatGPT what confusion. Here, what do you think we should have for X train? Have X train or X train before one hot encoding or after? Let's see what ChatGPT has to say. Correct. So it is saying when plotting the graph, we should have one exchange after one hot encoding, because this the indexes it is going to give the importance, this key, the model that is giving this feature importance. It is going to give on the feature, the data set that we had given, right? So yes, we are correct. And yeah, so this is how the model is looking. Let's um, add, let's add day, hang on, day 12, and commit the code, add code for day 12 onto main. Let's see. Yes, we can see it in our repository. So yes, uh, this is how we have completed today's problem. and we have learned what this. Let me go to the problem. Yeah, we have learned what this gradient boosting machine and how it works. We also saw and plotted two different type of graphs. So it was a really good day. Thank you very much. We will solve the next problem tomorrow. Thank you.